Yes, we are live. And maybe today we'll talk about Faust, and we have July with us. Uh, Maybe we can start introducing ourselves so that July can know what we are doing, and then let's start with Eric.
Um, yes, so Eric, been part of this group for since the beginning, I think. Yes, and we've experimented on robotics especially for space and so on. Okay, and more we see the technology changing. So recently we are pretty much, myself, pretty much interested in the intersection of robotics and crypto. Okay? Um, Otherwise, I'm an engineer, and I was a researcher also in the past. Okay, in AI. For what it means today.
Yeah, so I'm Anuraj. I'm currently based in Finland. So I've been doing robotics for around 15 years now. Yeah, I've studied space robotics in 2020. I think Venkat suggested let's start a Mars rover group. So that's why I'm here. Uh, yeah, that was in short. Currently based in Finland. And a lot of interest in crypto plus robotics. Yeah, I've been doing some experiments at home with that. Very good.
Yeah. Hey, I'm Venkat. Yeah, we follow each other on uh, podcasts. So nice to meet you in person. Yeah, so we've been doing this since 2020, like Anuraj said, and mostly it's been exploratory so far. We've done a bunch of random builds of both our own designs plus kit robots of various types. And I think we've done pretty wide ranging explorations of rover stuff with some gaps, like uh, I think power management and being outdoors, that kind of stuff. The harder pieces we haven't yet figured out, but I think we've come quite a long way. And yeah, I think all of us are very interested in what Foster is doing and like uh, attestations or whatever of reality in crypto space. That definitely sounds very interesting. Yeah.
I'm Mayor Fenster. I've also been with this group, maybe not from the beginning, I don't remember anymore. And I've also been dabbling on the side with robots and software for robots and robots being friends with other robots.
And I'm Rhett. I'm based in Seattle and am also a software developer. And I joined this group. I'm the baby on the group. I think I joined like 2 weeks later after everybody else or something. So I'm the new guy. Uh, so I joined because I was interested in kind of toying with hardware. In that like I used it. I kind of dabbled a little bit like in college and then gave up on it because software was easier. And so I spent all my time on software. Like, oh, let's get back into hardware. And I've done a little bit of it, but I still find myself spending most of my time poking at software. So that's full circle.
Yeah, I'm happy to give an intro a little bit as well. So I'm July. My background is mainly in software for physical systems, building drones. I've worked on autonomous vehicles, autonomous parking garage robots, autonomous submarines, so just various sorts of devices, vehicles mostly. I previously was at Kitty Hawk building flying cars, Larry Page and Sebastian Thrun's project, semi-autonomous. There were a lot of projects there. So I was on a team called Flyer. We worked on Kitty Hawk Flyer. I was there for about almost half a decade until the product and the whole project got shut down in 2020. And yeah, I mean, my interest primarily has been in sort of the hardware robotics and physical space for probably over a decade now. I've also just had a side interest in cryptography and distributed systems, and my friend was mining Bitcoin, I think in like 2012 or something, using free utility electricity. And I didn't think too much of it, but it was really more when Ethereum came along and I was interested in compute that was decentralized and really difficult to take down. And the idea of a world computer was sort of the first thing that really kind of caught my attention. And then from there, I was sort of generally sold on the idea. Again, I understand the financialization part is a big part of it. I've also just been really interested in it as a technology. So that's kind of how I ended up in terms of my interest in crypto. But yeah, mainly I'm been writing mostly software, and my background was originally more in EE, but now I mainly just write software for, doing embedded stuff, robotics. Not good in anything, but can do a little bit of everything, I guess. It's kind of my general. Happy to get into like specifics, but that's sort of the general overview. And nice to meet, I think I've met Eric actually in person when I was in Japan. But it's nice to put names to some faces that I think I've interacted with online multiple times at this point. So.
Yeah, everything you've said about FOST is like super intriguing. It sounds like the image you had and the vague description, it made me think of like Asimov's Psychohistory and the Prime Radiant device that's in the Foundation novels. But yeah, I'm really curious to hear more about like what exactly it is that you're building and how it's supposed to work.
Yeah, so I think there's a sort of further and distant future that I'm generally excited about, and I think to me the longer term is that I think physical vehicles, robots, and machines in the real world are going to are going to be the ones that are going to be driving a lot of on-chain transactions, because they're going to be the ones that are going to have sensors, and they're going to be having to prove to each other certain things and paying each other, and forming flash DAOs and doing things that are going to be inherently much easier for vehicles and robots and devices to do than it is for humans. Like humans clicking a button is inherently just going to be slow. But being able to make these decisions in near real time, being able to trust other parties, being able to do these things, it just makes sense. Like I think in the longer run, it's also a really great way for machines to have identities in the form of accounts or wallets of different sorts, or essentially private keys. So to me, it just seems like this is a good fit in the long run, and I think this is like one of those things that will happen. So that was kind of like the larger thesis that I was most interested in. And then we've kind of dialed it back like many, many times of what is this device that would sort of propel that future forward. Initially, we thought, okay, let's make an operating system, let's make a device that will tie this on-chain world with more of the physical world. Then it became more of a problem of, we built a couple of prototypes. We had an alpha device for this device that we call ROC, Reality Oracle Computer, about even last year. I think initially it was more kind of a dev kit. We'd sort of, what were we going to do with it? How were we going to get people to use it? Again, happy to kind of like go into specifics, but long story short, we've kind of dialed it down a lot. We've explored a lot of avenues. I think we've been on and off working on this. Part of the team has been working on it for probably like 2.5 years, and I've been probably working on it for almost 3+ years. So we've tried a lot of different things. And again, I don't think it's even enough to like vet everything, but we've done our best, and we kind of have a bet now. So happy to get into the specifics, but that's kind of the overview.
I think in terms of specifics, one thing that will at least help me understand what you guys are up to is I think of what you're doing as kind of like a crypto extension of IoT. And back when people first started talking about IoT, they had like a good toy example that communicated the concept, which was the refrigerator is running out of milk and it orders milk and the milk gets delivered. And that, even though it's kind of like a silly use case and probably not a very good thing to try and build, it kind of helped explain the concept of operations or use case or something. Do you guys have like a toy example like that that explains what Rock would do?
Yeah, so we kind of we've tried a lot of different things. Like we had, so maybe I mean I can tell you kind of what we're sort of about to announce, or what we're sort of been working on for the past little bit. Essentially, we have a camera device, so it's handheld, it's operated by a human, and the idea it's a camera that can take provably real photos in the age of generative AI. So we're just going to start primarily, even we've cut out sort of machine even out of the picture, just primarily focusing on an actual device that people could use to take a photo that, and why do you need something provably real? Well, as sort of generative AI and sort of just AI images or content becomes increasingly prevalent, and just sort of, just the amount is going to increase, then it becomes increasingly disorienting because you don't know, it's sort of like you're in a room or you're in an ocean and you don't know which way is land. So you need sort of reference points, like anchor points, in the same way that, when you wake up in the morning, you'd be able to, where the doorknob to your door is, because, the layout, you trust the layout of your house. And those anchor points, I think, in the real world exist because you can, your layout and you trust it. But in the digital world, if everything is sort of ephemeral, everything is copyable, then there's nothing that's real. So how do we kind of create that? Another metaphor I think of is if you're watching a sports game and it's a live sports game, then it feels different than maybe a replay that you're watching on YouTube, because the one on YouTube can be sped up, or it can be changed. There's no sort of action of consequence. With a real photo, there's nothing that you can really do about it besides the fact that it exists. So our hope is that by creating it, making it cryptographically provable that it's real, which is kind of the key part. If we distill everything that the Rock is, it's really just a sensor that is tied to a private key, and we have a hardware device that ties the sensor data to a private key in a secure enclave. That's really what we boiled it down to. We had a lot of fancy things. We initially had things where you could prove that you could move an arm. We had like a robotics element to it. We had many of these different things, but we've just cut it down. We even tried with a climate tech company that proving carbon dioxide through a flow meter, attesting how much CO2 was being extracted by one of these machines that sucks CO2 out of the air, and can you prove that and tie it to a carbon credit? We looked into like a lot of different ways that it could fit. It just we just kept kind of cutting, or we just sort of made it smaller, or So this is kind of the smallest version that we can ship, that we've realized is in the form of a camera that people can use. So that's kind of our first bet.
What's super interesting here is that you talked about several things we have talked also about, and I'd like to know what were maybe some of the reasons why you did not go with some of the scenarios. So, for example, to prove that the robot arm has done some work. Okay, we talked about that last week. For the one who remember, okay? Is basically to have a fabric on which me from here I could order somehow a lawnmower, a robotic lawnmower to take care of a lawn that is a bit away from a house, for example. Okay, so a bit silly example, but it sounds like asking for a robotic arm to do some work. Okay, and so I don't know. Personally, I would be very interested to know if you can share some of the reasoning why you didn't go that way, for example.
Yeah, absolutely. I think one of the main issues that we ran into multiple times was, are we a crypto company or are we a robotics company? And if it's going to be purely, so part of the things is that if you're doing some of these purely robotics problems, the robotics part is so challenging. I almost think of it as like there's a limited number of innovation credits you can use in the company. So, what are you going to make a bet on? And essentially, a lot of the robotics problems are inherently so difficult that the crypto part becomes borderline irrelevant when you're trying to prove or solve a problem that is, let's say, like, even something seemingly simple as moving a pallet from this one location to another location repeatedly. Maybe the pallet sizes are different. Maybe they come in different colors. Maybe there's just so many things that you need to deal with. And the issue that we kind of kept running into is we would end up, okay, well, are we going to solve more? Are we going to focus more on the robotics part, because that actually solves customer problems? But part of it, what I've been interested or what I've been curious about is what are the sort of technologies, what does blockchain enable in a way, or what does cryptography enable in this sort of coming world that wasn't possible and that other people are overlooking, that is possible with existing kind of components and existing technologies, and tying that together. What can we do in that manner? Became kind of more interesting question to me, rather than kind of this potentially pursuing kind of incremental innovation. And again, there's sort of big shots you can take in the robotics side, but then you would be completely not doing crypto. You would be just doing, building a foundational model for blah, 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 or something like that, So
Right.
There's different paths, and the intersection of crypto and robotics that I thought was interesting is the innovation is more on the crypto side, or the application of both together. And it would have to be some sort of established problem on essentially either side. And that's why we kind of started with something much more simple, like IoT, that is essentially already kind of done, but it's a good starting point to kind of do something that the combination is more interesting rather than anyway. The scope of the problem essentially was too big, is the long story short. It became difficult. And again, as a sort of research project, it's very fun. So I don't think there's any issue in that. But as a sort of business problem and sort of a larger kind of product that you might want to roll out, I think it becomes harder. If that makes any sense.
Oh, it does, yes. And does it mean by extension of the reasoning that now the use case you're talking about with the camera, okay? So the technology you're building is about so ensuring that it's not a deep fake, or that it's not generated, that comes from a real sensor. But you don't intend to sell the sensor. So that would be some kind of library for existing cameras?
So yeah, how the camera works is we have a camera device that allows for an actual like TEE, like a trusted execution environment in place. And then what you can do with that is that it allows for private key, like a hardware wallet that's tied specifically to the device, and the device will be able to sign sensor data that's coming in within this secure enclave. And there's various degrees of security that you want to deal with. So it really is kind of like, if you have a sort of city state and you're building a wall, you need to kind of consider how high do you need to build the wall, or how high do you need to build the security to repel the kind of attackers that you want to keep out. Starting relatively small, just because it's just going to be easier for us to do that. But I think that by allowing us to sign the data, it makes it so that this device could have been the only device that could have signed the data for the sensor coming in. And then using that, we generate a zero knowledge proof using that as inputs. So it could be the sensor data right now is like a photo, but it could be location, device ID, a few other things, and that gets inserted into the zero knowledge proof. The zero knowledge proof actually takes some time to create. I think it takes about a minute or two to create on the device, because it's actually quite computationally expensive. And once that's generated, it gets sent right now to EAS, Ethereum Attestation Service, and the proof is sort of on chain. There's nothing we can do about it, and the only address that could have signed and sent that is the device itself. Then there's sort of an on-chain and off-chain verifier that allows off-chain verifier, meaning just sort of essentially a proof verifier that runs off-chain to be able to check to see if certain elements of the photo are real or not. And then there's an on-chain one if you really don't trust, or if you want to prove to someone else that you're proving that this is real, then it's also possible too, and it's completely independent of us. Sorry if that makes any sense. And
Yes.
again, this is, I don't know if this is too detailed or if you want a little higher overview.
I think I could
Yeah,
use a couple of like clarifications here.
Okay.
So you've got a sensor, it creates like a raw sort of like data file of the image.
Yep.
That gets signed with a private key, and then there's like a zero knowledge thing that happens. And when that photograph is shared externally to random other sources, you can basically challenge the camera to prove that it was the one that took the photo, right? And that would be kind of like a chain of custody proof. But if you did something like, I don't know, took a screenshot of the photo on your screen, or like converted it from whatever original format to like a different format, this kind of like provable properties would be lost, I imagine. So this is only the claim that this particular set of bits was created by this sensor. This is the assertion being
Kind
claimed.
of. Yeah, so photo input is one of the inputs for the ZKP. So you could input, let's say, like in the longer run, if this is used, let's say, for like journalism and you're a war photographer, you can prove that this photo was taken 100 miles of Beirut or something within this time. So you could prove certain properties without exposing the actual information. So photo data could be one of the things. So in the longer run, you can even also prove certain, let's say, like a certain computer vision model running on the actual camera that proves certain aspects about the data at the time that you could also prove. Did you how many people did you see? That part, the probabilistic part gets a little fuzzier, but there's ways to sort of, it's not just the photo is really the point. It's sort of properties of the device and properties of other things around it. And also for fun, I think for this first version, we're also keeping a Farcaster key on the device, so that the Farcaster account, there's one Farcaster account that this device owns. I'm kind of fascinated by this idea of like machines owning their own keys that other people can't use. And I think that's the key part that's going to enable that's what I think is going to happen longer run in the future, where robots and vehicles and machines are going to have wallet addresses that essentially have private keys that other people and other machines can't tamper with. And if that's the case, then they have a provable way to interact as sort of real things in the digital world. And I think that's interesting. I think there's just a lot of interesting things that can come of it. So I think it's the first aspect of it, sort of the Trojan horse, is to kind of put the key in there and make it difficult to tamper with. And that is going to require some work, and we're definitely not there. This is not a production ready device that we're going to initially launch. It's a very beta device, but we want to see what people will do with it, and it's worth investigating that, I think. So and also not losing money on selling devices, because it is a hardware business, and hardware businesses are, I think part of the first year of doing Faust was after Kitty Hawk, it was so difficult that I'm never going to do a hardware or robotics company again, because it's just such a stupid business. It's so dumb, but I love building vehicles and robots and real things. So here I am.
You talked
Can't deny
something
my
about
passion.
Please,
you
Anurag.
talked something about EAS or something, Ethereum After Station. Can you go into
Yeah,
more
so
details
Ethereum
about
Attestation Service, for those of you that are not familiar, is I think an interesting kind of setup. It's two smart contracts. One is a schema registry, and another is essentially the EAS contract. You essentially set up a schema saying, here's the schema that I want to store, and then the registry essentially you send that to the registry, and then essentially whenever you call the EAS contract, you can send essentially some sort of JSON data, for example, that will always be saved on chain. And they call it an attestation, and those things are interesting. But what we think of it is it's a place to store it's a perfect place to store something like a ZKP. And of course, if you look into existing use cases of ZKPs, rollups are a perfect example of something that already does this, where they take a bunch of transactions, roll it up, and submit it to like mainnet for a lot of these L2s, and with varying degrees, there's sort of a different kind of expectation about more decentralization and everything like this. But with an initial device, it's sort of just like one device that's sending a ZKP. So yeah, that's just again, it's going to get more complicated, but that's sort of the initial first kind of stab.
And also the example of a single camera is very interesting in the sense that you can generalize that to any kind of sensor, basically, right?
Exactly, yeah. So we're calling the first one rock camera, and the idea is, who knows? Maybe the second one is rock mic or rock voice or other aspect like video. We looked. The initial thing that I was interested in was actually watching some of my watching some of the footage of recently war conflicts that have been going on, and thinking about how live footage, trusted live footage is such a difficult, if you could have trusted live footage, that would be such an interesting thing that you could do. I mean, it's sort of the equivalent of like a TV network broadcasting live sports shows or something like that. But you can trust, everyone knows that it's real, so everyone kind of trusts that it's happening. But what if you could do that with sort of like war zones, or what if you could do that with presidential elections or other things? And so that's where I initially started thinking about it, and then from there it became, I think I did the calculation, not even for a live footage, but to do like an hour-long video. And I think the proof on the device that the embedded device that we were using was like, it was going to take years to make the ZK proof. So it's like completely out of question. So then we're going to go, well, maybe we need to start with something much smaller. Maybe we need to start with a photo. But yeah, I think eventually there's ways to kind of, there's papers out there, people who have done, ZKP for video and ZKP live footage stuff as well. I'm sure like I haven't read some of those papers, but I've read some of the video ones, and there's ways to do it. It's just let's just start with something simple, essentially. If you're going to approach the building the everything store, why not start with books, which are going to be the easiest, instead of trying to kind of do everything all at once, or just start with the hardest one, because we don't know how people are going to use it.
What's the TLDR on why it's so expensive?
The TLDR on why it's expensive is it's a lot of math. It's a lot of math. So it's a lot of compute. Yeah,
I guess my naive approach, or my naive assumption would be like, you take a SHA-256 of a whole bunch of data, and then you do some cryptographic operation in the SHA-256 to attest it. Is that? And but SHA-256 is fast, so I don't know why is it slower than that?
It's because part of it is, in order to do like a SHA-256, you have to, when you have a SHA-256, you need the actual thing, like you need the actual data to then hash it again to arrive at the same hash when you do the SHA-256. So with the ZKP, one of the properties that's nice about it is that you can prove certain aspects of the data without exposing the data. So if you want to prove private data, like a photo, or you want to prove certain elements or certain data points about the actual data, you can do that without exposing the whole entire piece of data, because the data could be sensitive, and that preserves the privacy, and it also allows for sort of private attestations as well as public attestations. And it also provides more flexibility in creating the circuits for how you want to structure that data. And kind of in a way, how I see it is, this is kind of, this is a little bit of a different story, but like when I was at Kitty Hawk, one of the things, I remember doing an interview, like interviewing some potential candidates, and I wanted to send them sensor data because I wanted them to do this like homework task, for a position. And it just struck me like how difficult it is that there's no standardized way for sensor data, and it's like really difficult to share sensor data over the internet. I don't know.
CSV? No?
Yeah, it's like CSV, I guess, is great, but stupid me. I was thinking about ROS bags, and it's like now I have to send them like a ROS bag, and then they have to like figure out a way to like be on the same. Anyway, it's just like this whole. Maybe it's just a ROS problem, but it kind of started getting me thinking about like what. Yeah, it started getting me thinking about what like any sensor data. Sensor data is something that's not on the internet as much, so I think that's interesting. So like the internet is very human sort of created. I mean, obviously with large language models being the perfect example of that is it's like very human oriented, but there's no sort of like data set for machines. So that's I kind of started thinking about why is that. The second part is it's like, well, how do you trust if machines start creating this data? How do you trust that the machine data is actually real? How do you know that it's real if it's sort of being streamed in real time? And then so that was another sort of kind of path that led me more towards this direction. Because these machines are just spitting out so much. This is the other part of it, is the machines generate so much more data than humans do. The sensor data is massive, right? Like video. I think with some of the self-driving cars projects that I know, used to go to like drop spots as close to Google Cloud facilities as possible because you wanted internet. You couldn't. It was faster to send SD cards than it is to try to upload the raw specs, for example. It's because they're just so massive and it's useless endeavor. You might as well just send it directly to wherever, to the actual like Google Cloud facilities or something like that. So yeah, it's a lot of data essentially, and so again, it just seems like that's just going to be more proven.
Self-driving cars that have to drive themselves to the data center to unload their data. That's hilarious.
I mean, it's probably in Waymo's case, like for example, Waymo. I don't know exactly what they're doing nowadays, but like they're like all the offloading of data is probably happening on all the chargers, right? So they're buying all this. I don't think they're buying. They're leasing this land in certain locations, probably right outside of larger cities is probably their target. They need to charge these cars, and when they're charging, they're dumping the data off because they're plugged in and they're wired.
So it sounds like there's two reasons you want to use something like ZKPs. One is privacy and security concerns, like a journalist wanting to say, I was near the wall when I took the photo, but I don't want to reveal my name, but the photo was taken in this place, right? That's one reason. The other one sounds like it's just quantity of data, and something like SHA-256 would not work because then to verify, you might need to send a petabyte of data. So instead of that, you say, here's a proof that this is like really 1 petabyte of data with such and such properties or something like that, right? Am I understanding the two reasons correctly? Volume of data.
And I think I think like looking at something like an L2 to a L1 is sort of, there's a lot of the benefits, similar benefits as to why you would use a zero knowledge proof, because you want to preserve certain elements, ordering. There's a lot more that I think goes into, there's reasons, and again, not all of it will be relevant. The other thing too, I think this is sort of a completely tangential and sort of, if anything, more poetic licensing. But when we put it together recently, the generating the proof for the photos take about, I think like a minute or two right now to create. And initially that was kind of, oh man, we have so much work to do. It's going to take some time for these computers to get better and chips to get better and all this. But then I started thinking about this idea that we're spending so much. I don't know if I don't know if you're familiar with like EVE Online, but the whole idea of creating ships because you're exchanging time for ships, and that the ships become valuable because you're essentially using time and energy to like create these ships. And I kind of started thinking about that idea of it's almost like on one hand with AI, you're training models that take a long time. You're essentially sinking time into creating these very powerful models. And if we could kind of frame it for the person using the device to feel like they're spending time and energy into making the photos real, it's almost like a balancing act of all these people taking photos, and they're spending all this time, and they're countering sort of the ability for these models to create so much. I don't know. It's sort of more of a kind of poetic license.
It's kind of a
But that's my
cryptographic
pitch.
darkroom. You have to go in and develop the film.
Yeah, and there's something kind of
Indeed, yeah.
nice about it. It's the IKEA effect. Maybe you're spending so much time on it. You're like, this has got to be valuable, right? And it's not like we're making it up. It's actually, this is the computational limit that we're hitting right now with this device. I mean, we could also get a better CPU and whatever, but
I don't know. This sounds like this sounds like proof of work for its own sake. Whereas I think the more interesting value proposition is something like you're proving a realness that is actually valuable in some way. Like when you mentioned video, the first thing that came to mind was I recently saw this YouTube video, and you also mentioned sports, right? Like live sports have a value because of being live. And so that reminded me of this video I saw of like a guy debunking an ad where David Beckham was kicking 3 soccer balls in a row into trash cans like 100 yards away. And this was a famous commercial, apparently. I hadn't seen it before. But yeah, the video to an untrained eye is famous footballer is going and kicking 3 soccer balls and they're landing into 3 trash cans immediately. And this guy went into like excruciating detail of doing the trajectory analysis and showing that at some point it deviates from a parabolic arc, and therefore the second of the 3 kicks has been doctored. And it's like, okay, now that's valuable to me. It's not like I don't know, spinning your wheels proof of work, but this debunker guy clearly put in a lot of work to like analyze the photo and prove that it was like not real. Can you do some version of that automated? Like, can you like assuming you have lots of compute and like 5 years from now really efficient ways of doing ZKPs, could you like have a commercial that comes with a certificate that says this is David Beckham doing 3 kicks in a row, and it's provably true that this is not a doctored video? Is this?
Yeah, I think that's the goal. The goal is that, I mean, again, the sort of the poetic license, if anything, is just more of, I'm trying to spin it in a way because it takes a minute or two right now. So it's really more of a spin, if anything. The longer goal is really like creating provably real photos, or at least the sort of beginning of the anchor point into the digital world, where so eventually, like, I also see a future where a lot of these things, like, you're going to want data provenance of certain, you want to know, right? Like, if this photo depends on this other photo and this other photo depends on this other photo being real, you need the source of all of it being, you need the first bridge between the real world and the digital, like, sort of real world. And that is the point that we're solving first, which is connecting, trying to prove that this sensor took this set of pixels, really is what we're trying to prove. Like, for example, we're not trying to prove like GPS location. We're not trying to prove that you're in this location actually. We're just trying to prove that the GPS really did receive this information.
Okay. So
there's a
somebody could have
whole nother level of like so like, for example, like WorldCoin is trying to prove that this is an iris in the photo. We're just sort of one step below that, which is this. We're just trying to prove that this photo was in fact taken, for sure.
I'm worried about the contest between the cheaters and the trustworthy people, and I think you just put your finger on it. We have a photo, and we took it with your camera, and we have some bad actor who wants to fake the photo. So if that bad actor, for example, injects fake GPS data, we have no way of knowing. And really my question is, are you feeling, why aren't you actually playing whack-a-mole with these bad actors? You lock down part of the chain, and they simply start, cheating in a different part of the chain. Or do you feel that it's funneling down, and as you lock down more parts of the chain, it becomes more and more difficult to cheat?
I think the reason why is initially it's just hard to lock down that part to not cheat. Is like for example, like spoofing GPS is surprisingly not too difficult to do, or I guess unsurprisingly pretty not difficult to do. spoofing a lot of sensor data even is also not too difficult to do. So it just depends where are you going to sort of draw the line, and there's fidelities of how real is something, and right now we're kind of drawing the line initially at sensor data instead of sort of is this sort of objectively real or not. It's a much more difficult problem we discovered to try to answer that and get the fidelity and still try to be able to sell the device and make it useful. It's a lot of work. So yeah, there's other things you can do for. I mean, just even recently, Intel SGX, the TEE for x86 64 chips, like their root of trust was like their private key was exposed. So I mean, you're talking about a billions of dollars going into this, and they still can't even protect a private key. So yeah, it's a lot of work that I just don't feel confident that we'll be able to reach within a period of time that's possible with a small team. And so we had to draw the line somewhere, and we kind of drew the line at sensor data being real instead of the like real for lack of a better term. Yeah, and that's already a difficult problem, right? In robotics, I mean, you have all these other different sensors that you're running through different kinds of filters to try to guess what it's actually constantly doing. So
Yeah.
how do you even know if it's real or not? Yeah. So again, are you going to use like, how do you get ground truth? Like that's even an even more difficult question to answer. What is the ground truth for some of these things? It gets quite philosophical, I feel like, when you start kind of getting into the details. The further you go down into the stack of that, and the further you go down, the harder it becomes to prove. So I think we're starting with the easiest, which is just sensor data. Well, not easiest, but the sensor data.
So what you're working on is it some sort of library that you provide, which you can like basically use with any sensor or any compute platform, which allows
we tried to do that initially, kind of, but yeah, it's a little harder. I think the reason why we've kind of put it into a box, essentially camera with a button and a screen, is because we've kind of realized that we'll have the most control initially and the most control over the security aspect of it, and it's the most difficult to prove. It's like the how much work it is to how difficult it is to tamper with ratio is the highest currently out of the options. So if you build your own thing, then you have to kind of make it very secure on the software side of things. If it's just a library, if you build the hardware and you release the hardware, then other people have to write secure software. If you have the hardware and the software and you don't let anyone kind of in, then it's the easiest. So at least that's what we're starting with. Security wise, I think that's the best way for now. And again, not a security expert or anything like that, but we kind of figure it out as we go. Experts, I mean, whatever. Experts are experts.
So the compute platform you have built, is it like a desktop class or microcontroller or a single board computer?
So we initially started with a bunch of ST boards. Specifically, Zephyr RTOS has this thing called TFM, which is like Trusted Firmware Module. And so we wrote it in this RTOS. It worked pretty well. And then again, we ran into the problem of, we really want to use ZKPs, and this is just not going to work. So, and we want to build this prototype. We want to ship this beta version. So we looked at Jetson. Well, Jetson also, like, can we take advantage of the GPU? Jetson Orin Nano is pretty expensive. It's $500. It's a little too much. So we ended up at a Raspberry Pi 4 currently. And because it also allows for like CM4, the compute module can be broken up into. We can make our own boards, our own what do you call it? The extension boards. I'm blanking on the exact term right now.
So on the Raspberry Pi 4, then the zero knowledge proof takes 1 to 2 minutes basically.
Yeah.
Okay.
And that's with like 1.5 gigahertz or something like that. And it is an ARM Cortex, but
But have you tried any like
ARM64.
custom accelerators for the specific computations? You could have like a FPGA connected to the M.2 interface, and then you can use our Raspberry Pi 5. Basically, it has the PCI Express outside, and then you could have a custom accelerator for that. I'm just
I think that's
curious if you
definitely
tried
like sort of more next step, essentially.
Okay.
I think it's just easier to just do it all within a Linux for now and bite the bullet on making it as simple as possible for the time being, and then sort of iterate from there. So again, this is by no means like the last version of it or anything like that. And if anything, the Raspberry Pi is more of a hack. So that's the So there's ways to do it. There's also like ways. There's a lot of different ways to go about it. But I think FPGA. There's also like hardware, like ZK hardware that I think ZK chips that are going to come online. TBD on how good they're going to actually be, and I'm sure they're going to take some time to actually be who's going to like. And this is the other thing too, right? Like you pick something new, and then does it work? Is the company going to exist in like a couple years? There's all these sort of like considerations that just I don't really want to deal with. And like for example, if I buy like an embedded GPU today, I'm not going to buy essentially not NVIDIA because I don't know if they're going to be around or not in like 3 years. So what am I going to choose? Well, I'm just going to end up choosing like a Jetson board or an RPI or something that will do the job, or like one of those Rockwell GPU chips. Or Raspberry Pi variants. Like those are the two options essentially. So trying to be conservative because we're doing kind of risky project overall is kind of or at least been our path. And don't get me wrong, like we have a lot of boards. I've tried a lot of boards. I have a bunch of Jetson boards as well. Again, I've like, or Nano. I have like, we'll see. Yeah.
But you are joining DevCon.
TBD in that as well, but
Okay.
it depends on the timing of. We might be ready to launch a pre-order for this device next month, so we're kind of strapped a little bit on time.
Anuraj and I will be there, and we'll be bringing some of the robots we've been working on. So if you come as well, it'll be nice to have hardware representation.
Yeah, and again, I'd love to hear about some of those things as well. I know conversation-wise, it's been.
So I think what you see behind the red on the whiteboard is
I'm glad I didn't erase it.
Is the one what we have right now. So basically, Venkat and I have it running, and probably Mayor also will have it. So this is the robot we have, and then we replaced it with a ESP32, and then basically, can you go explain what's happening?
Yeah, what was this doing? Okay, so there's a ESP32 over here, and that was running on. So it's got Wi-Fi on it, right? And so it's attached to whoever's access point, and then and that's all. Like the software running on there is written in C, and it's using Platform IO. That's kind of the development environment for that. And then you use Serial to write to that. Then we've got our frame server, which is running on a laptop.
Laptop, yeah.
Yeah, and so that's got some IP address that we don't care about. That's it'll be like personal, but it knows about the IP address for the ESP32, and so it can actually send requests to the web server that's running on here. And then through a web browser, you can connect to this frame server and do like debuggy sorts of things. But the interesting part then is this ngrok component exposes this frame server to the internet through a URL that it generates, and then Farcast, any other clients can actually access through the internet this ngrok and get to this frame server, and then by proxy can send commands to the ESP32. Did I get all that right? I think that's right.
Yeah. So basically, you could control the rover from a Farcaster frame, and I think we set it up for Venkat 2 weeks ago. So if you go to the live stream of our channel, you will see that. And then, so there is something called Paybot on Farcaster. So right now I'm in works to get it integrated. So basically they gave me a API key. So and then after the transaction is validated, they allow you to move on to the next frame on the Farcaster frames. And then so my idea is basically if you pay a token or something, uh, it's like a token gate for going to the actual frame serve which controls the rover. But let's see if I am able to finish it by November.
And I can see a use case here directly for this camera of yours, because then you can provide proof that I paid $1 to control your robot to move from point A to point B. Give me some proof that I actually did that, and you can just fake it, right? Because it's fakeable.
We've had this conversation like internally for sure about like building how some version of essentially being able to actually control a remote controlled camera, being able to pan, tilt in whatever direction, and being able to take photos in a way that you can prove that you actually were able to do that.
Yep.
Definitely.
So the
really
idea
cool.
of that. So the idea of that Tumblr rover is we were trying to build a rover that we would send it to Mojave. And the architecture was have a Raspberry Pi and an ESP32. So the Raspberry Pi is not there yet. And neither the camera, but like that is the eventual plan.
So this is another
awesome
rover. There's a kit that Rhett and I are building. He has one, I have one. This is the Galaxy Sunfounder, and it's a 6-wheel rocker bogie that's similar to the actual Mars rovers. So this one has an ESP32 based camera, and the controller is an Arduino Uno. But eventually I hope we can get this one on the Farcaster frames controller as well. And in this case, there'll be an actual camera and like interesting possibilities there.
It's very cool.
One thought occurred to me as you were speaking, like if you abstract away from the, I guess the last mile, or in your case, the last 6 inches of the proof of or chain of custody chain, the general idea is actually very valuable. Like just earlier today, Anuraj posted something in our Discord about Dan Ariely, the famous professor, predictably irrational, all those papers. His most famous paper just got debunked for this exact issue. Like none of the authors are willing to like stand behind the original data that informed the study. So now the entire like theory that they published is in tatters. It didn't replicate, but non-replication is like you could argue that it can still be an honest outcome. It's like, all right, maybe you made a mistake and somebody else couldn't reproduce it, but if you can't even like produce the data or the protocol for the original experiment, like that's fraud. It's not just incompetence or you made like a genuine honest error, right? So it strikes me that apart from the robot camera part, if you leave that part out, everything that happens after that is applicable to this stuff. Like I can imagine like researchers doing social science research, maybe they're doing like some interviews with some game theory type experimental setup. You could probably like pre-register the protocol of that experiment and how the data was collected, and you could make a fairly rigorous case that at least I didn't cheat. My research may be crap and it may be a stupid idea, but I didn't cheat, right? So I wonder if that's actually in the future. Like already, so this I think, Mayor, to your point of like, are you just making it harder for the bad actors to act bad? I think it's already true in social science research. Like standards are rising now where people have to pre-register experiments and like provide the data on the result is based. Much harder to cheat, and you can make it even harder, I think.
Yeah, and I mean, I think you're already starting to see that with like a lot of even like AI and robotics papers that are coming out. Is it used to be people would, not even have a code base that would come along with the thing that they do, and now they just actually publish the GitHub and you can run it yourself. And albeit maybe the it's not like a breakthrough; it's more like an incremental change. But a lot of the code base is there, and it sort of helps people actually run it themselves.
It's still pretty rare for people to publish sensor data, though, right? Like as you said,
absolutely.
Like, there's no sensor data on the internet.
Now we finally on the internet.
We have
it's interesting.
But you have data sets for robotics, right? So you get like standardized data sets.
There is, but there's no this is another whole conversation I also went down of like I thought for a while about how do you get like real-time, real-world information about everything all at once. So like one approach is obviously the China approach, which is to install cameras everywhere, do it a top-down centralized approach. And that's scalable too for if you have, you know, an authoritarian government that can implement that in place and collect all that data. I mean, SenseTime, I think, is the company that does essentially, it's like Skynet as a service, I guess. Is like they're huge, right? Like they're collecting all this data. The other approach in a more liberal democracy, I guess, in Western countries, obviously we're not going to accept that. So what do you do? Well, it has to be some sort of decentralized way to share and validate sensor data with each other and create a infrastructure similar to maybe something like Helium, not necessarily with the tokens, but just sort of more the model of distributed decentralized sensor data being aggregated some way and shared. And that's the way that a lot of sensor data is going to have to come online. And also, like, where does that go? Who is going to host that sensor data? Is how valuable is the sensor data? Well, there's two types of sensor data that's valuable. One is immediate, real-time data is relatively important. And then the other that's less important, but very important in aggregate, which is historical sensor data. So you want to be able to train on sensor data or do other things. And sensor data obviously has a half-life if it's sort of in single data points versus if you have it in terabytes or a lot essentially. So yeah, but there's a lot of I'm really curious or just been curious. This is kind of like a weird obsession I've had with sensor data on the internet and how I can't find sensor data in a valid format. And yes, I look for ROS bags on the internet sometimes.
Yeah, we are reaching the end of the hour.
Thanks a lot. That was a really enlightening conversation.
Yes.
You should join our Discord server. So we sync.
Yeah, I'd love to
work
join.
together. Yeah. So like we discuss a
and
lot.
Yeah, I don't know
things.
how regularly I can join, but I'd love to like participate or help in kind of like whatever way that I can, as maybe a kind of roving sideshow.
Like what would be required? Let's say if we want to integrate your first hardware to one of our robots, is there some sort of API?
Yeah. Also, I mean, I can kind of share what, like, some way to, or at the very least, like, I can do a more detailed dive into the technical part and show you the what we're actually doing code wise. Talk about overkill. I initially started this sort of project with writing sort of like a ROS project for the camera because we, initially this was supposed to be a robot. So we started with ROS, and then of course over time that became kind of irrelevant. But yeah, so there's sort of different approaches. Another way is I'm also I got pretty deep into the more Zephyr RTOS stuff and TFM and how do you sign things. Yeah, and then there's also I didn't go into it too much, but there's this whole other conversation about chips and root of trust and how do you get a private key to be actually secure. It's a really difficult problem to have. Like, a hardware wallet is actually quite a difficult problem, and no hardware wallet is actually secure, unfortunately. Yeah.
You didn't try to use the hardware or the code directly from Tracer or something else because everything they provide is open.
We use Trezor. We use Trezor Fork.
Okay.
Yeah, for some of the stuff, for sure. I mean, it's very helpful, and again, it's battle tested, so I don't want to rewrite everything. Yeah. But that being said, it's not a it's less of a software issue and more of a hardware issue. So there's like physically unclonable functions like PUFs that you can get, or TPM, trusted platform modules, like actual chips specifically made to hold the. Anyway, there's just like a lot of, like, something has to someone has to take the responsibility. Something has to take the responsibility, and that thing has to be unhackable. And there's no unhackable thing.
Yep.
Is the short TLDR.
Yeah.
So you can make it increasingly
least-
harder, but it's hard.
Yeah, at least I would like to know have a more technical deep dive, like with what you can like reveal it to us. But yeah,
But yeah, I
You
think
can join
the thing that we were gonna do is essentially like a TPM with a Zephyr RTOS, like trusted firmware module, and I think that's probably essentially it's the same. Like it's the same problem with like how are you going to define what's real? You just have to kind of draw the line in the sand somewhere, and we drew the line in the sand with embedded devices and trusted execution environment with a chip that will hold. Anyway, so I can this could be a separate conversation. I don't
Yeah.
know. It's probably too late to talk about this.
The group is open, so we meet at this time every week. So any time to have a further, I think we can accommodate pretty dynamically, right?
yeah, and
Appreciate
then
it.
like we talk a lot on our Discord channel, so you just
Definitely happy to join the Discord. I also I have a 9-month-old and recent kid, so my schedule's kind of messed up for a little bit.
So for the
Otherwise-
nights when you can't sleep, it's perfect.
Yeah. But yeah, thank you for making this time and thanks for having me and thanks Anuraj and Eric for inviting me and everyone else for
We're talking about
accommodating and making the time.
Force and you quite often, so we want to know more.
Have a great launch.
Appreciate it. Thank you. Thank you. And and of course, like if we're able to meet in some place, would love to bring the device and when we do the pre-order, I'll definitely let you know and maybe we can. I'd be happy to kind of get one device donated for the group or something that people can play around with if it's of something that people want to do stuff with. So.
If you ever come up to Seattle, Rhett and I are here, and we'll be glad to buy you lunch and talk more. And I get down to the Bay Area reasonably frequently, so yeah.
Great. Yeah, I'm in San Francisco Bay Area, or I'm right outside of San Francisco. I'm in Pacifica, which is a small surf town right outside of San Francisco. So.
Sure, we'll run into each other.
Yeah, would love to. More than happy IRL to meet up.
okay.
And take a picture together.
Exactly, that you can prove. And yeah, I'll also be in Japan again later this year. So maybe I'll see you as well, Eric.
Okay.
Great. Thank you very much for joining. It's super interesting.
Yeah, thank you so much. And again, I'm like very excited about the future of the crypto robotics, and also, I mean, obviously, this is like a whole nother conversation too about the rover, and also I think I'm also I have other interests in space robotics and vehicles and other things as well. So sounds like I'm in the right place.
Yeah. Okay then. See you next week.
Okay.
Thank you.
See you.
Bye.
Bye.